All right, for most of the participants in here are members of the Thief River Falls robotics program. For those of you that aren't, my name is Robert Fay. I'm the coach here in Thief River Falls, and I've put together just a couple very basic things that I want to share out to you. I try and share these out with all of my students every year, just to familiarize everybody with the VEX code blocks that we use for the IQ robots. We have a number of them. I do have one of them here. I don't know if anybody's built this robot. This is this year's Robot Rise. Every year, VEX comes out with kind of a sample robot that can play the game. And this is this year's robot. I'll be getting into him a little bit more on the third set of this when we get into actually programming. But today I wanted to go through just some of the initial setup, the programs that I use, and then kind of starting in with the robot. So I'm gonna share a couple screens here. Uh, the first one, I just want to show you the two programs that I use, and I'll throw these links into chat for anybody that wants them. The first is VEX Code IQ. So this is the app. You can use this on a Windows computer, a Mac computer, or the students use it on their iPad. Um, we For any of the students that don't have it yet, you should be seeing that showing up in the next week here or so. The other thing that's important, uh, not for any of the students, but anybody that's uh, setting up any of these, is actually to get the VEX operating system onto your main computer. This is available for both Windows or Mac again, but this you'll plug in. This will make sure that all of your brains, your radios, your motors, they're all up to date with the latest firmware. So in Thief River Falls here, none of the students have to worry about that because I take care of that myself. Um, and it's very important that you do keep these up to date. And the main reason I say that is because when we go to tournaments in that, I know I go around to a lot of the teams to try and help them out if they're struggling with anything. And if I plug my computer in uh, to help with any issues you're having on your robot, if your firmware isn't up to date, the most current version, it's going to give errors when you try and do that. The other thing is, should you ever have a motor go bad and you switch it out with somebody else's, if your motors aren't to the most current firmware, they can give you errors as well. So always make sure you're kind of running it through that VEX OS and making sure you have the most up to date firmware there. So the next thing I'll open up here is, I'm still new with this Zoom, so you'll have to forgive me a little bit here. Is, let's see, is the VEX code uh, screen. So let me, oops, sorry about that. We'll get this up here. So this is the VEX code screen that you'll be able to open up again. This is going to look the same whether it's on your iPad, Windows, or Mac. You can use that with anything. And I'm going to want to go through some of the initial setup here with you. As we have this here, you'll see in the center, it's just going to say VEX Code Project. That means we don't actually have a project started. It will give you a not saved here. The brain right here is white. That means we don't have a brain plugged in or on the iPads, they're not linked. If you have the new radios, the blue radios, those will link via Wi-Fi from the robot to the app on your iPad uh, in the link here. So you'll see here we don't have a brain connected. The nice thing about the brains here is when you actually turn that on, it will automatically connect. So I'm going to go ahead and just turn mine on to show you. You'll see this brain turns green, and that means I'm connected. I can open this up, and it's actually going to give me the number of my brain. So I'm going to switch this over here, and I'm going to show you right on my brain itself, because this is an important thing for everybody to be able to know too, is if you're linking these with your iPad, you have to be able to find your brain number. So there's two ways you can do this. If I shut this off, when I turn it on, you'll see on the bottom here, it flashed really quick. There was a number. That was actually my brain number. But one other way I can do it is on the bottom, you see settings, hit the X. We're going to hit the X. And then we see system info, device info. So system info, we hit the X, and you'll see this little ID number right here, 300580. That's the ID number of my brain. So again, if I was going to link this to my iPad, I'm going to need to know that number, because when I click that brain on my software, I'm going to go back into this. So when I click this brain on the iPad, it's going to give me a couple options. I'm going to have to select the number that I want. So it's important to know that. When you're plugged in to a computer, it's going to automatically grab the ID of the brain that's plugged in. So right here, you can see it's grabbed that number, 300580. So I'm connected and ready to go. The next thing I'm going to do is I'm going to actually create a name for my project. So I'm just going to do Zoom example, and I'm going to save that. Let's just do this. There it goes. Trying to save in the wrong spot. So I've just saved this example as Zoom. You can name this as anything. For my teams, I generally like you guys to name these based on what we're doing. So if this is going to be a skills, we generally do skills 1. If it's going to be a driving program, driver 1, etc. The other thing you're going to have to pay attention to is slots. So each robot has 4 slots. So up to 4 different programs we can load into each brain. And we're going to want to know what slot we're going to load our program in. So if I'm going to load Zoom into my robot, which slot do I want? Right now, I don't have any in my robot here, so I could pick any one. It is important, though, if you say load a skills program into one or a driver into one, and you're going to load something else, that you put it in 2. Because if you leave it in 1 and you download it, it's going to automatically erase that first one. So we have to make sure we're paying attention to what slot we put it in. You can put it in any one, even if there isn't a program in 1, you can put it in 2, 3, or 4. So it's good to pay attention to that. The next thing you're going to have to do is along the top here, you're going to see a little button. It's shaped just like the plugs in our brain, and we're going to click on that. And when we click on that, we get the option to add a device, and we're going to click on this to add a device. Now, when we look at adding a device, we have to look at what kind of program we're gonna write. If we're writing a skills program that's going to operate autonomously, we're not going to be adding a controller. If we're looking to create our own drive program, then we're going to want to add a controller. Drivetrains, 2-motor drivetrains, 4-motor drivetrains. So two motor, obviously, it's going to have just 2 back drive wheels. 4-motor, it's going to have 1 motor on each wheel. Most often, that's when we're using Omni wheels. So 2-motor is the most common we use for most of our teams. So I'm going to click into this. Now we have to select our motor in our port. So we'll just go down and we'll be able to do a couple things. First, we have to pick a left motor versus right motor. I generally do this from the back side. So if I'm standing behind my robot, which motor is to the left? You trace the cord from that. So looking at mine, my left motor comes up and goes into port 1. So I'm going to select port 1. And then it automatically switches over to my right motor. I'm going to look at mine. Mine goes to port 6. So I'm going to automatically select that. The program automatically asks you if you have a gyro. I do not have a gyro currently in my robot, though I strongly recommend using the gyros. For anybody that hasn't used the gyros before, they really help with making sure your robot turns 90 degrees to the left, 90 degrees to the right, etc. I know a lot of my teams have experience. They program the robot to turn using the wheels, and depending on the weight, if you're lifting something, pushing something, a wheel slips a little bit, and instead of turning 90 degrees, we turn 70 degrees, and then the rest of our program is off. So I'm not going to select this gyro. If you did have a gyro, you could just select what port that's in. Now, because I do not select a gyro, I'm going to get a few more options here. Wheel size, this is going to ask what size wheels we use. There are a few different options here. These are the standard options that you can get if you have a tire kit. Where the track width, again, one thing to keep in mind, this is listed in millimeters. If you're doing measurements in inches, you can just click and change this. And one thing I also want you to pay attention to is when I change that, this first number changed. So one thing that's tricked up my students from time to time is that they change this first number to 100, and then they go over here and they change this to millimeters, and you can see that changed that number. So change the measurement first, and then change the number if you're going to do that. This question mark just helps explain this, but track width, we're going width, and this is to the center of the tires. Wheelbase is going to be the length, and this is the length from axle to axle. So you can measure that. Again, we're looking at what that measurement is. And what that's doing is that's just putting in information to help you know if you're driving and you say turn 90 degrees to the left, how far those wheels have to turn. And then gear ratio. So if you do have your motors geared, if they are not direct axle to wheel, you are going to have to put a gear ratio in here. And again, this is going to help us when we get into coding because we get options that are uh, drive forward 12 inches, for example. And if this gear ratio isn't right, we'll go 12 inches, and it's only going to actually uh, go forward 1 inch, or it's going to go forward uh, 12. So let me add that. So let's look at a few other devices. Well, actually, before I do that, I want to point out we added a drivetrain, and one thing you'll see is as we continue to add devices, more options are going to show up on your code blocks on the left. So uh, when you initially start, the only options on the left are going to be what's pre-programmed or what you can do with your brain the way it's set up. As we add things, like right now, there isn't anything over in this list that's going to have a button for a controller because we haven't told it we're going to use a controller. But if we add a device, so say we're going to add um, our controller to drive it, we're going to click on our controller. I'll walk through the setup on this. So here we've got a controller. Now the only thing we've set up so far is the drivetrain. We haven't added any other motors. So most of our buttons aren't going to do anything. The ones that will do something are going to be our two round joystick buttons. And if we click on those, you'll see off to the side, it's going to give you a little animation of the robot. So if I was to click done right now, it's actually going to program this robot to drive forward, backwards, and turn just using the left joystick. Now, if I click on that again, you'll see it switches it over to the right joystick. I'm going to click on it again. Now it gives, I believe they call this arcade mode. The left joystick is giving you a forward, backwards. The right joystick is giving you turning. Click this one more time. This is tank drive. So your left joystick is controlling the left wheels. The right joystick is controlling the right wheels. In Thief River Falls, this is our most common used method of driving. Uh, uh, this varies a lot depending on student preference. I do have one group of elementary students this year that is attempting to use the arcade. They found that more similar to some of the games they've played. So they're trying to drive their robot like this. A lot of the students at my middle school are using tank drive because as we built our claw bots when they started in elementary school, tank drive was what they were using. So I'm going to leave that and we're going to go done. I'm going to add one more device here. I'm going to add a motor, and I'm going to go back, look at my lift or my rise robot, and my lift motor here is hooked up to port 10. So let me throw one in here. And my motor, I'm going to name this. I like to name this because as we get multiple motors, most years we have two or three that do different things. By naming these, whether they be lift, claw, push, it's a little bit easier in the program to understand what they're doing. When we get here for forward or reverse, we can switch this. Often uh, what we do is if we have, say, two motors on one axle, we will forward one, reverse the other one. Um, this again is normal. You can click on this. You can see it reverses the direction here. You can go back in and change this too if you find, you program something one way and it doesn't work right. The only thing that needs to change is a reverse. You can go in and click the reverse. So I'm done with that. Now I want to hop back in here just to show you guys something that's changed on my controller. So now that I've added another motor, I have all of these buttons highlight, and I'm going to choose the R button, the right, up and down. I'm going to click on that, and you'll see my lift motor has now been added, and it shows forward, reverse, and I can click on this, click on this side, sorry about that, and you can see this switches that setup. So very, very easy to switch that. Could change it from a lift, lower, forward, reverse again there. So, and I can do this with anything. If I click this, so it's gone, I could choose my F buttons here. Again, lift, switch my arrows, forward and reverse. So wherever I want that to do. Now, as we add more motors, you can put those where you want. If you want them to do different things than just operate that, we'll have to do that through some of the programming. And what I mean by that is, say lifting, for example, and we'll get into this in some of the examples, is if when we push that button up, we want it to say only lift 3 inches instead of just lift as long as I hold it. That's going to require some programming that's a little bit different than just pushing that button. So let me close that. So we've added a controller, a motor. We'll look at some of our other sensors here. They're very easy to add, very similar to what we've already added. So a bumper, again, this is just a push button. Again, we add it, we select a port. So I'm going to select 2. Again, I like to name these depending on where they're at. So we'll go no space. So front bump, if I was going to have 2 of these, we'll do that. And there isn't anything more to the bump sensor. Distance sensor. So I don't know if anybody in Thief River Falls has used these yet, but these are ultrasonic distance sensors. They measure the distance between, say, the robot and the wall, the robot and an object. So we'll get into that and how that works. The gyro, again, this is one that's used for turning. We generally use this on the robot as a whole for turning, but you can also use this for other things. If you had an arm that was turning a certain degrees, and that you could use this to help verify that you've turned that. So we're going to add that. Touch LED. So touch LEDs are a capacitive touch sensor. What that means is you don't actually feel a button press, but when you are pushing the top of that, it senses that you press that and it can act as a button. It's also an LED, so we can use that for color signaling. We do that a lot here in Thief River Falls for programming, we'll write multiple programs for one robot, and we'll use one bump sensor to change the color of the LED, and depending on the color of the LED, we'll run a different program. So like this year, for instance, for skills, you can either be on the left side of the field or the right side of the field. And from the left side of the field, you're likely going to turn left and run a program. From the right side of the field, you'll turn right and do that. So we like to use touch LEDs to help the kids be able to see the code changes and make sure, say you're looking for orange, the LED would be orange. So we'll add that in there. Our list is getting a little long. So color sensor is another one. It's something we could use this year. We do have a couple different colors of risers. I'm not sure I've seen it used for a couple years really heavily, but the light sensor can pick up in sense color right in front of the sensor if you're trying to do some autonomous sorting of different objects in the game. The last sensor will be the vision sensor. I'm not actually going to cover the vision sensor because so far this year they haven't made it legal for IQ play. It is legal for the VRC. I imagine that's coming down soon because it's available. If that's something you want to start using, we can certainly have that conversation and look at that. So I'm going to go back up here now, and I'm going to cancel this because I'm not going to add anymore. So as you can see, I've added a number of objects here, and we have the ports that go through that. And with each thing that I've added, you'll see we've added a number of things now. If we go over here and we look at looks, we have a touch LED. For events, we have when, and we have a bumper. We have our touch LED, so those are active events. We have our controller here, so we can program based on interaction with our controller. We go down here to sensing. We're going to motor sensing is actually happening inside of our motor. We have our calibration for our gyro, so we can calibrate our gyro inside of our code. It does automatically calibrate when it starts. Our color sensing, so we're sensing near objects or sensing the color when we get near an object, and our distance sensor. So all of those have popped up because of the things we've selected over here. And then we have operators and variables. We'll get into those. Those are really important things to use, especially as we want to build a more complicated code for our robot. So I wanted to come back and show you just a couple more things on our brain that are also important to know. So obviously we have our base driver control. We use that for a lot of our basic builds. We also have these slots here, but something that's more interesting that a lot of people miss is if we go down here and we go to device info, and we have all of our port information here. And so this robot here that I'm showing you actually doesn't have anything more than just 2 motors hooked into it right now. We have one on port 1 and one on port 6. So this one is showing port 1. But what I want to do is show you that you can go into this and you can turn the wheel and it'll actually tell you how far you've turned it. So right there, I just turned it, and this angle number right here where it's showing -76 is showing you that that wheel has turned -76 degrees. Now this really helps us when we get started. We've actually built a robot, and I'll show you like Rise here. So we built this robot, and I've decided I want this to lift 15 degrees. And I can actually go into the port that's hooked up to this lift motor, and I can see it at 0. I can lift this up. Make sure. I can lift this up to where I want it to be, and that will tell me on the screen how many degrees. It's really easy as we're just getting started to take our robot, and we can actually push it on the field forward, say 12 inches, and we can read that screen and see exactly how far we've turned right here just using this. So I can continue to turn this in any direction. I'm going positive, and it'll show me how many turns I've made. So, you know, right there, I went, my angle, you'll see my angle right here is 358. And now I've went over 0 to 4, but my turns went up to 1 turn. So I can continue that through, and we'll see that my wheel keeps adding turns. So for instance, right now I'm at 3 turns plus 94 degrees. So we can do a little bit of math if we need to know how many turns we're actually doing. And that'll actually work for all of our sensors. If we plug our LED in there, it'll tell us what color it is, and it will tell us if we're pressing it or not. Buttons, it'll tell you if it's not pressed or pressed. Distance sensor, it'll actually give you a readout of what it's reading for a distance right now. The gyroscope will also show you turning. The gyro is a little bit harder to read because the gyroscopes naturally reset. So it feels it turn, and it gives you that turn, and then it goes back to 0. So it's a little hard to watch that on the screen. You can get some pretty good ideas if you're watching it live, but you're not going to be able to turn it, leave it sit, and then see that because it resets getting ready for the next turn reading. So my screen. So I'm going to go in here. I've already showed you that. Drivetrain. I'm going to go ahead and delete this drivetrain. I want to show you the other one just so we have it. So four motor drivetrain. The one they have in here is going to be 2 motors on the left wheel, 2 motors on the right wheel. This is not how most people set up their motors if they go 4 wheels. So if that's something that that you're looking to change, that where you have them independently driven, you will have to program that. Again, most common in IQ is we're only using a 2-wheel drivetrain because we're limited to 6 motors. So the use of 4 motors here, we lose. Again, if we leave a gyro here, we select that. As you can see here with the gyro selected, we have less options. So again, if I go back, if I don't select that, it's going to ask for this track width, track base. So that I think is our basic setup. So again, we get in, we select our slot. We're going to name this so we can save it. We've hooked up to our brain and we've selected our devices. Once we're to a place here where we're going to start program, I like to save this, and it's saved here on the screen, but I can also download it to my robot. If I click on download, you'll see it'll gray out while it's loading, and then it comes back white. That means it has actually loaded onto my robot. So if I go to share now the screen, you'll see my number 1 slot is now Zoom. So I've loaded that into my brain. Now, obviously right now, it's not going to do anything because I haven't started putting program in here. The one thing this robot would do is, because I've added a controller in here and a drivetrain setup, if this was correct, and it's not set up correctly right now for my robot, by adding a controller in a drivetrain setup, my robot would be able to drive. So if we wanted to just simply, if we just wanted to simply set something up to be able to drive, but we didn't put it in the standard Clawbot setup ports, we could simply just add a controller, just add a 2-motor drivetrain, and set up our controller to whichever method we wanted to drive. Tank drive, again, most common. Click done, and we download that. Our robot, using that Zoom program on the brain, would be able to drive just with that base program. So I know I've kind of covered a lot here. So let me see here. Do you know how the H drive would work? You'll have to kind of clarify that for me, Michael. Were you talking about saving the program?
How the drivetrain would be set up. The H drive has the 2 motors on the side and then the 1 Omni wheel in the middle.
Yep.
So it's the H drivetrain.
Very, let's see, I'm not sharing. I have something like this one right here.
Yeah.
Yeah.
Yeah, is that programmed the same way as a normal drivetrain, or is it?
This is not. This would actually have to be programmed in using the variables. So you would program it with the, let me see if I can get back here. I'm still kind of new with Zoom, so you'll have to forgive me a little bit. But we can program this based on, where am I? Using your controller buttons and what they do. you can program this to turn, and it's a little bit complicated setting that up. Um, I'll have to dig through. If that's something you're looking at programming, I think I have an example of that I could possibly send out to you. It
That
does
would
take,
that would be awesome.
yeah, it does take a little bit of um, setting everything up, but I know there is a number of people that that do that. In fact, that's one of my elementary groups was starting to build that, um, thinking it would be a little easy. But yeah, there's a little bit in just the setting it up for the turn, because I know one thing some teams do is they actually set it up for what am I going to say here? They set it up using the tank drive, uh, which allows you to drive forward, backwards, and do the turn. And then they use a different set of buttons for the side shift action. And the if you do that, the only thing that's different with that is there are some settings in the motor setup, and I'll go through that a little bit more next week, where you set your center wheel to either hold or release, and based on what your robot is doing would uh, change that. So, for instance, your center wheel that you have. Let's see, do I have it up here? Oh, right here. So you set the. I just have the lift here, so I'd have to have a separate motor for this. But you can set this to coast or hold. And what you'd want to do is when your robot is driving forward, you want your center wheel to hold, and that prevents your robot from drifting left to right. And when it turns, as far as like making a 45-degree left turn, your center wheel is going to coast. But then if you want to do a left or right shift or crab walk, for instance, you actually can set your other wheels to hold, and you can crab walk with that to make sure, again, you don't get any drift on that. A lot of that gets into how deep you want to get and how precise you want those movements to be. Um, this is also a very important, um, break, coast, and hold are commands your students definitely want to use. And if they're first getting into program, this will be one of the things that they'll miss and won't quite understand. Say I do a lift and I lift to lift a riser up, for instance. It's up to where I want it, and I let go of my button and the arm comes back down. um, that's because I didn't put a hold in there. So I lifted it. When I was done lifting, the arm just drifts back down. Um, I need to put a hold in it, so once it lifts, it stays lifted. When I come down halfway, it stops. Brake is something you put in that is going to stop uh, motion. So as you're driving forward, you want to put in brakes to stop when you're going. And I'll go into some of those tips, because that's something, depending on the different blocks you choose to use. Um, when you just say drive forward, it's often missed that, okay, I push this button to drive forward. The robot just assumes it's going to keep driving forward unless it hears a different command. Uh, where we also have blocks that, for instance, say drive forward 12 inches, then it's only going to drive 12 inches. So um, some of those little things I'm going to talk about them, but until you miss it that first time, it won't catch. So I know there's a few students in this group that have went through that with me where, oh yeah, drive forward, and they don't understand why the robot doesn't stop. We just keep driving forward. Well, we have to tell it to stop once we're going. So.
Awesome. Thank you.
All right. Any of you guys, I have a number of students in here from my group. You guys have any questions on the basic setup where we've gotten to today? For anybody that came in a little bit late, I did share my email address, robert.fay@digikey.com. So if you do run in here next week on Tuesday at the same time, I plan to actually start going through and explaining a lot of these code blocks and what they do. We're going to try and get through all of those, or at least the main ones that we use. If we get through those, I'll start throwing some basic code in there. Otherwise, the week after, we will get into that. For any of the adults on here, if you do add the VEX code in here, once you get past the setups and you see this, you'll really see some of these things come together. A lot of the basic things are really easy. Just when started, drive forward. Essentially, that's bit of code, if you downloaded it, would make your robot drive forward 200 millimeters. So, but again, like I said, next week, I'm going to go through, explain the blocks so everybody understands what the blocks are. And if we get through those, we'll start doing a little bit of code. Otherwise, the third week, which would be December 15th, is when I'm actually going to go in and do some of those examples for everybody. I'll hang out here for a couple more minutes if anybody does have any questions. Otherwise, thank everybody for coming. For the students at Franklin, remember we have a team meeting on Thursday via Zoom. So I'll see you guys then.